Buddy. Hey guys, so based on some of the questions I've been hearing in my classroom class as well as on the discussion board, I wanted to throw a couple quick videos up having to do with working with objects, specifically objects that contain records of data. So like we're referring to with the Module 2 milestone, where we're holding basically a contact record, and as well as how you can arrange those objects in an array. So for this video, I want to talk about creating a class so that we can have some very simple data objects. I'm going to set up a new project for this, and I'm going to run through this pretty quickly, but it's a video, so you can always rewind and recap, and the code that I create in this demonstration will be available in the Module 2 folder in Desire to Learn. So starting up a new project here, I'll just call it Objects Demo. I want a main class, so I'll put in my LCC username and then a dot, and I'll call my main class main app, and this will be where my main method is located. NetBeans will generate that for me. I'm going to clean up these extraneous comments here. All right, so we got a class with a main method, and what I would like to do for this demonstration is work with a very simple data object. So something like I don't know, let's say we're running a store, a retail store, and we're doing inventory control, and so we need to store some product data. So something like welcome to the inventory system. Okay, and we're going to need to capture some product data. So we're obviously going to need a scanner. And I'm just going to go right into requesting some data from the user. Enter a product name. The import our scanner here. Okay. Enter a price for, and then we'll stick the name in here. And the price will be a double. For now. Let's see, double. So when you use next double, if you recall, anytime you use scanner next double, the scanner will only retrieve the numeric characters that the user types in on their keyboard. And when the user hits the enter key at the end of that line, it'll stick an extra enter key into the scanner that does not get consumed here. So usually when you use sc.nextDouble or sc.nextInt, you need to follow that up with another sc.next line to clear the scanner buffer. Okay, and we don't assign that the value returned here to anything. It's just to get rid of any extraneous characters after entering in that number. And for each product, we're going to track the products in our inventory using the UPC, so Universal Product Code. Enter a UPC for name. Okay. It'll also be a string. Okay. Retrieve some data. So after we've retrieved this data, this is where we would need to store this data into some kind of object. So to make that working with that data a bit more convenient for us, it's kind of the focal aspect of object-oriented programming. So in order to create an object that's going to contain all of this data for us, we need to define a class. So I'm going to come over here to my package, do right-click, new Java class. I'll call it products. And I'll get rid of the extra comments here. I just want to focus on the code for now. And there are 3 pieces of data that we care about for this product that we gathered in the other class in the main app. And those are going to be the fields of our object. Remember that a field is essentially just a variable that belongs to an object. So every time we create a new product object, it will have the space reserved to hold these pieces of data. So we already talked about them on the other class, private string name, private double price, and private string UPC. These are defined just like any other variable, except they belong to product objects. They're not defined inside of a method. They're just defined as part of the product class. And because they're not static, these fields will belong to the actual product objects that get created. So for each product object that gets created, there will be a name, a price, and UPC. They're also different from regular variables in that we are giving them a visibility modifier. And the private visibility modifier signifies that these variables can only be accessed from inside this product class file. You cannot, from a different class, from a method in a different class, access these fields directly. They will need to be accessed using getters and setters, otherwise known as accessors and mutators. And so NetBeans makes it very easy to generate the getter and setter methods that will allow external classes to modify these fields. You can just hit Alt-Insert, and a code completion menu will pop up. There's a lot of options here. We're going to be looking at a couple more of these shortly. For now, I just want to select the option that says Getter and Setter. And that will pop up a little helper window that will ask me for which fields do I want to create a getter and setter, and I want to create a getter and setter for all 3 fields. And that will generate those methods for me. Now, people often ask the question, you know, we could solve this instead of making all these methods, because this is 6 methods that we introduced for 3 fields of data. Instead of creating all these methods, why don't we just make these fields public and allow them to be externally modified? And I guess the best way to demonstrate why this is important, this is often referred to as the principle of encapsulation, which states essentially that the only entity in the world that knows best how an object works is that object itself. So these products need to be aware of their data. They need to have complete control over their data. If we wanted to restrict the ability to, say, change the name of a product, then we could just eliminate the set name setter, and now the product's name cannot be changed, and it gives that object the necessary control over its own data. Another good example would be that the person developing this product class for creating product objects may have some specific knowledge that they need to enforce specific requirements. Like, let's say, for example, that the person developing this class is aware that UPC, a universal product code, must be exactly 12 characters. So one thing that that developer could do is in the UPC setter add some kind of condition like, let's see, if not UPC UPC dot, I'll redo my logic here. If UPC dot length not equal to 12, don't worry about exceptions here. We'll be reviewing exceptions. This is just to demonstrate a point. The person developing the product class who has more intimate knowledge of how products are designed could put this condition in here that would cause any tests or anyone messing around with this product class would cause their code to crash if they attempted to put in an invalid value for UPC. Now this is different than validation. This is called, basically fail-fast testing, which means the product designer is putting this in here not to validate the UPC, but rather to warn the people testing this code that if they allow incorrect values to be input in here, it will crash. It will fail immediately. So this is important protection, and one of the key reasons why we use encapsulation, so that the person designing the products class, who is aware of how products work, can put these kinds of safeguards in place. So now we have a very simple product object with getters and setters, and we can now come back to our main app and actually create a product object. This is, as you recall, just like creating any other variable, except we are going to use the new keyword and the product constructor, which I'll come back to in a second, to actually initialize the value of the product. All right, and then we're going to store it in a product variable called P. So now we can call that product methods, take the values that we've already read in from the user, assign them. Okay. Prior to doing these assignments, actually I'll put the note over here, let's go back to the product class. Until we actually assign values to these fields do all have a default state. So when you first create this product, the name field is going to be null by default. The price field is going to be 0 by default. And the UPC will also be null by default. All primitive types, like double, have a default value. The objects, like string, and you can tell they're objects because their type begins with an uppercase letter, it's a class name. Objects like string don't have a default value. Null signifies the absence of a value. So this is where we could run into trouble if we tried to do, before we initialize these values, if we tried to do something like, let's see, p dot get name dot equals. All right, since where this is positioned right now, this is before we have actually assigned a value to the product's name. This would put this on the line before actually. This would throw a null pointer exception, which, as you may be aware, would crash the program. So we don't want to do that. All right. We just want to proceed to assign the values. And once we've assigned the values to the object, it would be nice if we could print that data back out just to verify that it's correct, that it was entered and stored in the object correctly. This may seem a little strange because we are passing a variable to the print line method that is not a string. All right, the type of P is product, and we're going to pass it directly to the print line method. Every single object in Java can be converted into a string value through the toString method. And by default, it's basically going to give us some gibberish. I'll run this real quick and show you what this is going to look like. And then we'll figure out how to customize our objects to avoid that. So let me give this a run. And we'll put banana into our system at $1 and give it a UPC. It has to be exactly 12 digits or it'll crash. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we get our product data printed out, which is not really in a useful form. Basically, all this tells us is that we're printing out a product object, and this is actually a unique identifier for that object that Java uses internally and is completely useless to us. That is not what we want to see when we print out our object data. We can customize that, though. We can customize what our objects look like when they get printed out to the console by going into our class definition for product here. And I'm going to jump the cursor down to the bottom, and I'm going to hit Alt-Insert again to bring up this code generation menu. It's going to be very helpful for us. The next method that I want to implement here is this toString method. All objects have the toString method. It's inherited from the object class, the parent class for all objects. And the toString method is what allows any object in Java to be converted into a string. By default, not too useful to us with the default value that it provides. So by selecting this from the code generation menu, it's going to override that default implementation. And NetBeans is even going to ask us which values would we like to have printed out as part of this object string representation. I want to include all of the values. I want all the values to be printed out. For your module 2 milestone, you'll have to do something like this. The formatting of the string should be a little bit different for that milestone and for the module 2 project. But for right now, just to see the data that's contained in this object, this toString method will serve our purpose. So now I can run this again. I'll put in banana, $1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and now we can actually see the product data printed out. Okay. So we've got a usable product object here. There's one more piece. If you're kind of viewing this side by side with the module 2 milestone and what you're trying to accomplish with your contact objects, there's one more requirement for the contact objects that I haven't talked about here, and that is implementing the comparable interface. And basically what the comparable interface allows you to do is to compare data objects primarily for sorting purposes. And unlike toString, which is automatically present for every object in Java, in order to implement the comparability, you need to attach an interface to your class. So if you need a refresher on interfaces, you can look that up in the book, and there is a section on specifically the comparable interface. So I'm going to put in here implement comparable. And as soon as I do that, I'm going to get an indicator from NetBeans that I'm missing a method. The comparable interface requires a method called compareTo. If I come over here to product and hit Alt-Enter to get my code assist, again, that's Alt-Enter over any of the red squiggly lines in NetBeans to get the code assist menu. I can select implement all abstract methods, and that will add the compareTo method to the bottom of the class, which has by default just an exception throw in there to make sure, again, that the code fails if we don't do this part correctly. So I got rid of that exception there. What we actually want compare to do is one of three things. Compare to returns an integer value. And the important thing to remember about compare to is that if the objects compared are equivalent, then return 0. And if the first object is less than the second object, return a negative value. The textbooks, typically like to use -1, +1, but it could be any negative value returned here. And then second object is less than first object, return a positive value. So this is going to do one of three things. We're going to end up with one of three different integer values, depending on how we want to sort our objects here. So I'm just going to create an integer called result. And so I'll give it a default value of 0. And then we're going to do our logic here, and then we're going to return results. Okay, so all right, so if the objects turn out to be equivalent, what do we actually want to compare these objects? We've got choices here. Basically, what we're going to establish here is what fields do we want to use to sort our objects. Do we want to sort our objects by name? Do we want to sort our objects by price? Do we want to sort them by UPC? For the Module 2 milestone and the contact objects, you'll want to sort them by the ID fields. That's what's required for the project. In this case, let's sort by name. All right, so in order to do this sorting, basically the first object that we are comparing is the object whose compare to method is getting called. Let's go ahead and make this a little bit more clear. So the first product that we are comparing is this, the object that we are currently inside of. You can get a quick refresher on using the this reference in the chapter readings for this module as well. Okay, and then the second product that we are going to be comparing is this parameter, the parameter that's passed to the compare to method. Which by default is going to have the type of object. So we're going to need to cast that in order to do the comparison we want to do. All right. So when we're referring to these rules for the compare to method, we have to keep in mind that the first product is this product, the product whose compare to method is being called. The second product is the parameter object that is being passed in. So if we want to sort by name, we want to confirm whether or not the first object's name is equal to the second object's name. All right, think about this line carefully, because remember that for doing a string comparison, you have to use the string equals method, okay? If the first object's name is equal to the second object's name, then result is going to remain 0. All right, if they're not equal, we're going to do an else here, an else if. If they are not equal, we need to check to see whether or not the first object's name is less than the second object's name. Okay, one way we can establish that. is by using the string compare to method. Okay, so just like we're implementing the compare to method for products, the compare to method for string will tell us whether or not one of these values, the first value is less than the second value. Basically, if the string compare to method returns a negative value, so a value less than 0, then we also want to return a negative value. And finally, if they're not equal and one is not less than the other, then we can say pretty conclusively that the first one must be greater than the second one. So the second one is less than the first one. Okay, so these are the three possible outcomes. We're either going to return 0, we're going to return -1, or we're going to return 1, depending on how the first product's name compares to the second product's name. Now, I went through a lot of steps here to explain how to set up your compare to method. What I've done here is actually far more complex than required, especially for the Module 2 milestone. So think about how you could be writing this comparison in more of a brief fashion. It's going to be a bit easier for the Module 2 milestone because you're going to be comparing integers as opposed to comparing strings, which is just inherently simpler to do. Okay. Now, the main purpose of having a compare to method in place is primarily for sorting objects. So if we had a whole series of objects and we wanted to sort them by name, we would need to have a compare to method in order for Java's sorting algorithms to operate. For right now, our application is just reading in a single product variable. Obviously, if we want to deal in multiple products, we're going to want to introduce an array. And I'm going to separate the discussion on plugging products into an array into a separate video. So this is the conclusion of the video on setting up a class for simple data objects, which is basically going to consist of private fields with public getters and setters, as well as a toString method and the compare to method. This is all that's required for the Module 2 milestone. There is one more piece that I wanted to throw in here that is not required for the Module 2 milestone, but you may find it convenient to implement this regardless, which is to put in an additional constructor for this data object class. And I like to put constructors in between the fields and the other methods, so towards the top of your method list. And remember that a constructor is essentially a method that gets called at the time the object is created. So you can also use NetBeans, as I did for the getters and setters and as I did for the toString. You can use NetBeans code generation to generate constructors for you. Very convenient, save you a little bit of time and energy. It's the first option under the generate menu, which again is Alt-Insert. So I'll choose constructor, and it will ask me which fields do I want to be supplied through the constructor. So basically, which fields do I want to be supplied at the time that this object is created? I want to create a constructor that acquires all 3 fields. So I will generate that. Okay, so now I have that constructor requires all 3 fields. Now, keep in mind, or maybe this is new information, but when you create a constructor for a class in Java, it eliminates Java's default constructor for that object. Basically, what that means is, by default, all Java classes have a constructor that looks something like this. Just an empty constructor. Does nothing, requires no parameters. By default, every class in Java has this, even if you don't write it. This is why, with no constructors, over in the main app class, we can still construct a product object. This is calling that default constructor. as soon as you introduce your own constructor, Java eliminates the default constructor. So now I've updated this to include a specially generated constructor, custom constructor, and now Java will no longer recognize the default constructor. What I would generally prefer, and I say generally, but almost always, what I would almost always prefer is that if you are going to create a custom constructor, make sure you also explicitly include the default constructor, so that I have the option, if I am testing your data object classes, I have the option of creating those data objects with no parameters using a default constructor. It doesn't have to do anything, does not have to set any default values. You can just leave it empty just like this. But if you have a custom constructor, you really need to also explicitly provide a default constructor. All right, so that's my video, quick video on just setting up a basic data object class. And this is going to segue this little mini project I'm working on here that I will upload. Is going to segue nicely into the next video, which is talking about putting these product objects into an array.